Hi, this is Mrs. Lyons. This PowerPoint should help you figure out how to name and write formulas for compounds that contain transition metals. Before we can go too far, we need to figure out what the transition metals are. So if we draw a line that separates the nonmetals from the metals, remember I'm going to put an X through the metalloids. All of these elements, beginning in group 3, all the way up to the metalloid line, are the transition metals. And the transition metals are special because if you remember, we couldn't figure out the charges for the transition metals or their number of valence electrons just by looking at the periodic table. So, what do we do with this special group of metals when we want to include them in compounds and we want to do chemistry with them? First of all, when we're going to name something with a transition element in it, we're going to write the name of the metal. We're going to include a parentheses where we're going to put the value of the charge. We have to figure out that charge and we're going to write it as a Roman numeral in the parentheses, and then we're going to write the name of the nonmetal. So let's see what exactly that means. So we're going to start by using some examples. So Cu is copper. That falls into that transition metal area, so we need to include a parentheses and we need to include a Roman numeral. We'll figure that out in just a minute. Cl, we know, is chlorine. We're going to change the ending to IDE, so copper chloride. The only problem is now we have to figure out what the charge is on copper. Okay? Remember that all compounds have to be neutral, so the positive charges and the negative charges have to balance out. So if we look at our periodic table, we can see that the charge on chlorine is -1, right? We have 2 chlorine atoms in this compound. So 2 times a -1 gives us an overall -2 charge. That means that we have to have +2 charge to balance that out so that it's neutral. If you look, because there's no subscript, that means we only have 1 copper. So that copper has to have a charge of +2 in order to balance the charges of the compound out. Okay? One way is to look at it. We have 2 times -1 equals -2. And then we have 1 times positive, the charge on copper is +2, equals +2. So these have to equal each other. Let's look at another example. FeBr3. Fe is iron. It's a transition metal, so we have to have parentheses. Br, we know, is bromine. We're going to change the ending to IDE, so bromide. Again, we're going to look at bromide. We have 3 of them. If you look at the periodic table, the charge on a single bromide is -3. Okay? So, if you multiply 3 times -1, we get an overall charge of -3. That means that we have to have an overall positive charge of +3. We only have 1 iron. That means that 1 iron has to be +3. 1 times +3 is +3. So we have to have a Roman numeral of 3 for the iron bromide. So it's iron 3 bromide. Let's look at another example. Mn, don't confuse it, it's not magnesium, it's manganese. O is oxide. Since manganese is a transition metal, we have to have a Roman numeral. Okay, let's look. Oxygen on the periodic table is -2. We have 7 oxygens, so we have 7 ions with a -2 charge. That's -14. Manganese, we have 2 of them, so it has to, those 2 manganese have to add up to +14. What does the charge have to be on 2 manganese? 2 times what is +14? The charge is going to be 7. Alright, so we're going to write that like this, a Roman numeral 7 in that parentheses. Last one, CrS3. Cr is chromium. We've got to have parentheses. S is sulfur, so we're going to change the ending to IDE, sulfide. So we've got Cr and we've got S. If you look at your periodic table, the charge on S is -2. 3 times -2, -6, total negative charge. Means our total positive charge has to be +6. How many do we have? We have 2 chromiums. So what do each chromium have to be? 2 times what is +6? +3. 2 times +3 is +6. So our charge has to be +3. Okay, that's the hard part. The next part is writing formulas. So we're going to write the symbols for both the atoms in the compound and their charges. The charge on the transition metal is the Roman numeral. Okay, the charge on the transition metal is the Roman numeral. We're going to crisscross charges, and then we're going to simplify. So let's look at tin 2 chloride. Tin is Sn. The 2 tells us that it's a +2 charge. And then chloride is Cl. Look at your periodic table, it's -1. We're going to crisscross charges. So this is going to be SnCl2. Okay? Lead 4 oxide. Lead is Pb. The Roman numeral 4. If you're not familiar with Roman numerals, look at the back of your periodic table. There's a list of them. Okay? 1V, IV is 4, so the charge on lead is +4. Oxide we know is -2. We're going to crisscross our charges, and we get Pb2O4. Notice one thing, both of these can be divided by 2, so this is one we have to simplify to PbO2. Alright, 2 more. This one is chromium 3 iodide. Chromium is Cr +3. The charge tells us this is +3. Iodide is I with a -1 charge. So we take the charges, crisscross them down, which gives us a final compound of Cri3. Last example, nickel 2 nitrate. Look at your periodic table. Nickel is Ni +2. That Roman numeral 2 tells us it's got a +2 charge. This one, notice the ATE ending. That should be a clue. Go look at your polyatomic ion chart. Okay, nitrate is NO3. The whole thing has a -1 charge. So this gives us both a transition element and a polyatomic ion. We take our charges, crisscross them down, remember outside of the parentheses. This gives us Ni parentheses NO3 parentheses 2. So nickel 2 nitrate is Ni parentheses NO3 parentheses 2. Hopefully that helps you with how to write formulas and name compounds containing transition elements.